All right, let's get into it. When we think about science, we usually picture this pristine world of objective, truth-seeking geniuses. But what happens when that trust gets broken? Today, we're going to pull back the curtain on the uncomfortable world of scientific misconduct and go way beyond the headlines to see just how deep this problem might actually run.
Whenever a big scientific scandal hits the news, the story we almost always hear is this. It's the work of one lone wolf, right? A single rogue researcher. The thinking is, hey, the system is fine. It was just a few bad apples. And you can totally see why that's such a comforting story. It means we don't have to question the entire institution of science.
And it absolutely protects this powerful, almost sacred image of scientists as these totally objective seekers of truth. But when huge scandals, we're talking faked stem cell lines or doctored images in the world's most prestigious journals, just keep happening, it starts to chip away at that image, and it forces us to ask a really, really important question.
Is that bad apple theory really the whole story, or is it just the tip of a much, much larger iceberg? To figure that out, we have to stop relying on anecdotes and start looking at what the data actually tells us.
So what happens when you ask scientists themselves, but you do it anonymously? How many would actually admit to, faking it? And maybe even more telling, how many have seen their own colleagues doing it?
Well, a huge meta-analysis, one that combined the results from 21 different surveys, came up with a number that seems kind of small at first, but is actually pretty shocking. When asked directly, almost 2%, that's nearly 1 in every 50 scientists, admitted that they themselves had fabricated, falsified, or modified data at least one time. But get this. Here's where the whole picture just flips upside down. When they asked a different question, have you seen a colleague do it? That number absolutely exploded. More than 14% of scientists said, yes, I personally know a colleague who's committed fraud. Just pause and think about that for a second. That's a 7-fold difference between what people admit to doing themselves and what they report seeing others do. That gigantic gap strongly suggests that the self-reported number is a major underestimate of how big the problem really is.
And here, you can actually see the data behind that 14% number. This thing is called a forest plot, and it's how scientists combine results from a whole bunch of different studies. Each of those little squares is a separate survey. See how some are higher, some are lower? But that diamond at the very bottom, that's the magic part. It's the combined average of all of them, landing right on that 14.12% mark. This shows us it's not a fluke. It's a super consistent finding.
And here's the real kicker. Even these numbers are probably too low. The scientists who did this huge analysis believe that because these are such sensitive questions, and because a reputation for honesty is everything in science, this is almost certainly a conservative estimate. The real number? It could be even higher.
Okay, so we have a sense of the scale, but what are we actually talking about here? To really get a grip on the problem, we need to be clear on our definitions. What exactly counts as scientific misconduct? Well, according to U.S. federal policy, it really comes down to 3 main things.
First, you've got fabrication. This is the most blatant kind of cheating. It's literally just making things up out of thin air. You invent data points, you create experiments that never happened, and you report them like they're real.
Next up is falsification. Now, this one's a little more subtle. You're not inventing data from scratch, but you are twisting it. This could be anything from digitally manipulating images to cherry-picking your data and just dropping the inconvenient points, or tweaking the results just enough to make them seem way more important than they actually are. So, let's put it simply. Fabrication is creating fake data. Falsification is taking real data and making it tell a lie. Both of them completely poison the scientific record. They just take different paths to get there.
And the third big one is plagiarism. This is straight-up intellectual theft. It's using someone else's words, their ideas, their results, and passing them off as your own without giving them credit. It might not distort data, but it's a huge breach of ethics, and it totally undermines the whole system of scientific discovery.
And listen, this is not some new problem. Way back in 1830, the famous mathematician Charles Babbage was already writing about the temptation for scientists to cook their data, to clean it up a little too much to give it that appearance of perfect accuracy. It's a line that researchers have been walking for centuries. So, if this has been going on forever, how do we actually catch it today?
Well, the good news is the scientific community has built up a pretty serious arsenal of tools to hunt for fake science, and these methods are getting more and more sophisticated all the time.
Generally, these detection methods fall into 3 main buckets. You're either checking the text for plagiarism, checking images for manipulation, or checking the raw data for statistical red flags.
For textual concerns, the fight has gone high-tech. These days, journals routinely use incredibly powerful software, like a program called Authenticate, to scan every single paper that's submitted against a massive database of everything that's ever been published. It flags any suspicious overlap right away.
Now, spotting a manipulated image is a lot trickier, but here, there are specialized forensic tools that can see things the human eye would miss. They can detect these subtle signs of digital tampering, like elements that have been copied and pasted, or weird changes in contrast that give the game away.
And finally, for the data itself, we now have statistical watchdogs. There's software called StatCheck that can literally read a paper, find all the statistical tests, and just recalculate the results from scratch. If the numbers in the paper don't match the recalculation, well, that's a huge red flag for either an honest mistake or something much worse.
So all of this leads us to the biggest question of all. Why does this matter so much? I mean, these are just academic papers, right? Wrong. Scientific misconduct has incredibly serious real-world consequences.
For one, every time a scandal breaks, it erodes public trust in science as a whole. It also wastes a phenomenal amount of time and taxpayer money, with countless other labs chasing dead ends based on work that was completely fraudulent. And when we're talking about medical research, the stakes couldn't be higher. It can put our health at direct risk when treatments and policies are based on made-up data.
Which leaves us all with a really tough question. Science is, without a doubt, our most powerful tool for understanding the universe. But knowing that the whole process is run by human beings who have the same pressures and temptations as anybody else, how do we hold on to our faith in what science can do while also having the right amount of healthy skepticism? It's a delicate balance, and it's one that the scientific community, and really all of us who depend on it, are still trying to figure out.